as far as introduction is concerned. Is it okay? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So can anybody can tell me what is data mining?
So it's a technique to convert raw data into some useful data, like for some purpose in some companies.
Okay. So what you said is that raw data to some useful data. Is it?
Yes, sir.
Okay. Somewhat okay, but not fully. Or anybody else?
So it is a process of refining raw data into structured data.
Raw data into structured data. Okay, fine. What do you mean by structured data?
So it means like mm, mm,
Do you mean like that the data must actually follow some sort of a template for storage? That is what you mean it, or the data input and data actually visualization actually consist of some pattern, some sort of set of rules. That is what you are looking for.
so I think it should be the structured data is more categorized on parameters. I should.
Okay. Uh, Acha, can anybody can tell me, like, suppose you all are actually surfing your websites and all, like you have gone through so many pages, web pages and all. Does this web page is structured or unstructured?
Unstructured, sir.
Unstructured. Why?
So because when we scroll the pages, it's not like when for example, we have scrolled 100 pages, created an Excel file and stored that data that this is 100 pages data, 100 websites data, then we can't find anything insightful from that Excel file that what was I was looking for, what I was looking for while scrolling these sites.
Okay.
It's not kind of structured that we can't find any insights from that.
Okay. What I think she said is actually why we call it as structured. Actually, normally web pages are semi-structured rather than unstructured and fully structured. And some of the pages might be unstructured fully, or some of the pages might be structured fully. The reason is simple. Like when you scroll multiple pages, if uh, suppose you have fixed some sort of say portion of the page that it always be giving you the data which is in same format, so that is structure. Like suppose if I say that the some data is changing over the pages, say in the first page it comes as some image is there, whereas in next page when you go it comes like text is there, the same place text is there. So that means it is not structured, it is unstructured. That means it can take any input. If I say that if I fix that, oh, image will be there at this place, and every time the page goes on, if image appears, then it becomes structured, that you have actually fixed that particular position for a particular format of the data. So that is what certainly that has nothing to do with data mining. Just I think probably let me complete your definition. Just I think one of your classmates said that it's a raw data to sort of useful data conversion is data mining. Uh, Somewhat okay, but actually when you look for data mining, it actually talks about that you have huge amount of data, maybe small to large or maybe big also, and what you're looking for is that you're looking for a knowledge. When I say, that means some pattern which is not known to you. Is that okay? So some pattern which is not known to you. uh, Can anybody tell me that what sort of pattern I'm looking for? Is that something is always we look for a new or novel pattern? Or so when I say that new pattern, in two ways I may have that this thing. One is that pattern already exists in the data, but we do not know. If I can evolve that part, that also becomes a new pattern or a novel pattern. And another thing is that pattern is actually not in the data. Rather, I have to process it. So once I process it, I'll get some pattern which is useful for me. So that is also a novel pattern, a new pattern. So two way I can have this. So actually mining is a process which actually deals with pattern generation rather. Or you can say it's like we see there are so many synonyms we use it. We sometimes we say data archaeology, we say that knowledge data discovery, sometimes we say data digging, knowledge digging. So there are so many synonyms for data mining. Data mining deals with actually operates on data, but it actually does not talk about data. uh, Data storage is something different. Like you have databases which where you can store it, like database always store in a structured format, whereas data warehouse when you look for, so it actually data warehouse is a tool where actually you can store a huge amount of data. Only the thing is that data warehouse is not meant for application oriented data, rather than it is meant for subject oriented data. I'll let you know what is subject oriented and what is what you call it as application oriented. Application oriented is very simple. You can visualize that if I say library information system, so this is actually an application. So I need to store the data in a view of application, and I'll actually manipulate the data in view of application only. So students may be a part of that library, faculty may be a part of that library, some other entity may be the part of that library, but the entire arrangement of the data storage and manipulation always revolves around the library manipulation, rather than focusing on a student, teacher, or books or something like that. Certainly, all these will be the component of that part. So that is what we do in databases. Whereas, uh, if I say warehouse, then certainly, in case of warehouse, we only deal with the subject-oriented data. Reason is that it actually talks about historical data rather. That means we are not looking for application. We are looking for some data which from which I can have information, I can have knowledge, I can have pattern, which may gives me some idea to take some decisions for the future, maybe say actions and all. It may help you in that. It may benefit you in that way. So that is what warehouse has different modeling also, has is having different manipulations as well, and it is actually meant for historical data storage. Okay, so that is what we do it. So okay, I'm just sharing my first slide, which I'll what I'll do is that since you have gone through some introduction part, so I'll just introduce one figure which actually tells you that what actually data mining is. Okay, so let me go to that. Is it visible? Hello?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay. Uh, so you can see that uh, if you look on the figure, you can see that the mining process is actually, let me just a minute. So mining process is at this stage. Whereas you can see that this part actually talks about data warehouse. These are databases, and this data cleaning and data integration is also part of that. And we have some data transformations as well out here. Whereas out of data warehouse, you actually retrieve some sort of task relevant data. Task relevant data means that means you may be looking for some pattern specific to the some set of data. So when I say some set of data, then that means I'm looking for some task relevant data. So we retrieve task relevant data. Certainly this part always be covered through some, like it can be done through Oracle, DB2, MySQL, or anything we any software or any application program you can use it. And then go for mining, data mining. Data mining is actually is a collection of algorithm. Uh, when I say algorithm, that means I'm talking about some methods. Namely, I can have categorization, I can have discretization also, I can have associations, I can have classifications, I can have clustering. So I can have many category of algorithm in this. And obviously in each category of algorithm, you will find set of another set of algorithms, uh, which might be varying in terms of data size, in terms of scalability, in terms of complexity and all. So that also, that is actually data mining is. Okay. So what actually this figure actually tells you that uh, this below these cylindrical boxes, you can, if you look on these what we are actually looking for is that suppose if I take the example of any university system. Say one university is maybe 50 years old. So I'm looking for data to be warehoused of all the 50 years. So what you have is actually the data maybe 50 years back, means that means I'm talking about 70s or 60s and all. So over the years, you can find that the data format has been changed. The software and application programs which were used has been changed. So over, like, maybe every 5 years, there is a change in the software, there is a change in application program, and there is also change in the data also. So it might be the case that some data initially was stored in some file system, then later on it might be gone for some DBase or FoxPro or maybe COBOL. Then later on maybe MySQL, SQL, and then Oracle, and later on it is actually recently you can have DB2 also. You can have any advanced databases like NoSQL or SQL or R or any systems which you are looking for. So what you have actually is that I'm looking for 50 years of data to be warehoused. But what we have is a chunk of the data is in different format, and as well as in a different application and software also. So then what you require is that you need to integrate all these. Certainly that integration requires some sort of middleware applications. Say, like, that means you have to create some application interface through which two different format of the data can interact each other, because certainly I'm looking for a data of a same domain. So that is the first thing which I'm looking for. Another thing is that over the years there may be a case that there is a possibility of noises in the data. So I'm looking for cleaning it as well. So for that, it is actually data cleaning. The third thing is that you require some sort of data transformation as well, because the reason is very simple. Like, suppose what you have is, say you have date of birth. So in some cases it is actually DDMMYY. In some other file or other applications, you write like birth date, and it is following MMDD and this. So this format is there. Now I know, or you may be aware of that this is something is talking about date of birth, and it is actually having format this and this. When you want to integrate such data, or need like to join this data, because both data is actually talking about the same thing. Okay, so the problem is that system will actually detect this as two different data. Same is, the reason is very simple, that the name of the attribute is different. In one case it is DOB, another case is date of birth, birth date, and the format is also different. So here we require some sort of transformation also. Okay, so that is what required, that either they make this particular format uniform, either change this to this or this to this, or also you need to change this also, either you make this to this or this to this, or you can create another one, new one, which and need these two will be transformed into that. So that sort of transformation required when you look for joining different set of data. So that is what transformation talks about. Transformation is not only this, but that requires some sort of mathematical, statistical, probabilistic way of doing it also. Sometimes we make use of interpolations, sometimes we make use of wavelet transform also, sometimes you make use of normalization also. Like in some cases, like when you have that, suppose in maybe 20 years back, say some data D is having a different range of values, whereas the same data D now it is different range of values. When this such thing happens, then we look for normalization also. Say I may go for 0, 1 normalization, I may go for some other normalization also, like Z score is there. So such normalization factor also be used for data cleaning and transformation. And then when you clean the data, when you transform, make it uniform, then I'll be and certainly you have to create some application interface through which multiple data or heterogeneous data can interact each other. Heterogeneous in terms of data, format, software, applications, everything. Okay, so these heterogeneous data need to interact or to talk to each other so that it can be integrated. So once you do that, then whole data will be pushed to this warehouse. Certainly warehouse will have some modeling or some model structure. In that model, it need all the data will be mapped, and then you will have data warehouse. Okay, so it is very clear, data warehouse is very different from DBMS, very different. Okay, DBMS, as I told you, that it is actually application, when you talk about application oriented, whereas warehouse is subject. Warehouse is subject oriented when you talk about data warehouse. So it is actually DBMS is application oriented and data warehouse is subject oriented. Okay, certainly I have seen that your syllabus is having this warehouse component also. So I'll talk about some warehouse component as well. So now I'll be just going for data mining part. So what you have is, you have data now, which is of maybe 50 years data, 30 years data, 20 years data. Out of that, I'm looking for some knowledge or some pattern which might be useful for the, maybe for company, for manufacturing unit, maybe for university. It may be useful. Like suppose in case of university, the past data of students might be useful for me to design a new course for a present scenario. And I can see the trends, or I can visualize the trends from all past data, that how these trends are going, is changing over the time and all. So such information is very useful for creating futuristic applications and all. So that way it is very useful. So we go for task relevant data first, which is nothing but it's a this task relevant data is nothing but it's a sort of, you can say it might be a SQL query, and this query is actually a complex query, very complex query. Okay, it can take a length of anything, and I can actually mention all my requirements within this complex query. And this query could be in any, like it can be in Java also, it can be in C++ also, it can be in DB2 also, it can be in MySQL also, it can be like whatever is useful for you, you can have. And then once you have this data, task relevant data, now I'm looking for data mining. Data mining technique, that means I'm looking for some algorithm which can be useful for me to implement on this so that I can get a pattern. Okay, let me tell you that the issues which is involved in this particular you can say let me just erase this. The issue is with this data mining and pattern generation is that it is not only that you go for algorithm to be implemented, it is not only that patterns are generated. The issues will be there. That first issue will come, that which algorithm you want to implement. So decision of choosing an algorithm is a big task. It is not easy task anyway. Okay, so you need to focus on this part. That I can say that I have 100 of algorithms available, and out of 100 of algorithm, I'll be using one for me for the task relevant data which I have. Now the question is, it is not easy to choose. So what we do is that, looking on the background knowledge of the data, if I am aware of the domain, then I can have, and I'll be well aware of that what sort of patterns I can go for it, then I can actually choose some set of algorithms which might be useful for that domain. Say I can go for, say, okay, fine, I can go for 3 algorithms which might be useful for this. So I can take 3 algorithms. What I can do is that I can apply all 3 algorithms on the data. Then I can compare the accuracy of the algorithm. Like there are so many ways of, like I can go for error collections. I can go for say accuracy in terms of what percentage of data is falling in that category, or it is actually giving the perfect association or clustering or sort of classifications. So that might be my criteria. And certainly I can make use of any mathematical or statistical parameters which can give me idea that which algorithm is good for me. Okay, so that is what I can do here. Now once I say that okay, my X algorithm is good for me and I am going for it, then the problem with this pattern generation part is that the algorithm can generate n number of patterns. When I say n number of patterns, it could be 1, 2, 50, 100, thousands, and maybe more. So the question is that how to get the optimal one out of it. Then this pattern evaluation part comes in picture. Certainly we have to evaluate the pattern first, and which one is useful for me, I can declare it as knowledge for me. Otherwise, I'll discard the pattern also, because certainly 100 and 1000 patterns might not be useful for me, or might not be visible to select also, because that actually creates another set of problems for the decision makers. Because normally decision makers are CEOs and directors or managers of the company, and they might not be aware of all technology which you are talking about. So I'll be looking for evaluation part, and certainly I'll evaluate all the patterns based on, like, normally we make use of that. What is the novelty level? Then what is actually what we call it as Novelty, then confidence. Confidence, then utility. And one more thing which always we look for is simplicity. So we look for that the pattern should be simple enough so that it can be good for all set of peoples which are involved in decision making could understand that. Certainly the pattern should have high utility. That like fixing the utility part could be different depending upon domain. Whereas confidence, I can actually mathematically prove it. That and then novelty. That means whatever pattern you are looking for, it should not be known to the system. That means whatever pattern I'm looking for, I got it, should be novel and new in nature. So that is what we made it. And then upon these criteria or these properties, if any pattern falls in that, then I can say that it's a knowledge for me. And and that is why we call it as, this entire process is known as knowledge data discovery. Okay, so it's a core of knowledge discovery process. Fine. Any questions you can ask me on this?
So, so the after the pat, sir, after the pattern evaluation, how do we do the pattern recognition? That part is not clear to me. If you could just explain it once more.
No, no. What actually, what the question, please repeat the question.
So the pattern, sir, after we are done with the pattern evaluation, which one are we supposed to choose? So the pattern choosing of the correct pattern, that is not clear.
What I said is I'm looking for, like, pattern should be simple. Simple means uh, that is something which could be easily understandable. Okay, that means I should not present something pattern where actually I cannot understand, or somebody cannot understand that what is actually this pattern talking about. So that simplicity we look for. Novelty, that means simple, that is not known to the system earlier. This particular pattern, when I say, like, suppose if I say that, fine, I'm aware of few things, like uh, that suppose if a manufacturing unit is there, I'm looking for demands and all. So I may be looking for some pattern where actually people are saying that, okay, the particular product could be of this shape, this color, or something like some sort of things are very much well known. But there may be a case that out of uh, say mining and pattern which is coming, that fine, uh, there could be that, okay, size of this particular product of size is this, and of color this, these two combination of thing could be very much popular, or could be in future could be popular for the market. So this is not known to that system. That means system was not aware of, or the company is not aware of that I could go for this particular size or this color in combination of that. So if that particular combinations you can evolve from out of that your mining process, then that could be novel for you. Okay, see, sizes is unknown, colors are known, but the combinations could not be could be something unique which is not known to you at that part, and now you are aware of that, and that can be used as knowledge. And decision makers can take decision on that whether I should go for it or not, depending upon utility part. Because as I'm saying, pattern could be novel, that means something could be novel, but you have to see that how far it has the utility also. That means practically, say, when I say a product, or when I say any sort of things which is related to the market, then you always look for that what is the utility in the market. But it might be the case that product is very good, it might be the case this product is very attractive, but whether it is good for the market or not, whether market will accept it or not, that also matters a lot. So that part we'll have to see. Confidence, when I say, that means I'm talking about a probabilistic way of doing it. That means what degree of confidence you are having. So confidence may vary from 0 to 100. The 100 is 100% confidence. That means we are highly confident about that one. Or if it is low, then, and certainly it is not always the case that you will be having a high confidence for all the domain. Okay, fine. Like suppose if I'll take one example, that okay, if I say that in Ranchi, Big Bazaar sort of retail market, I think you have gone through it. That what is the demand? What will be the demand for, say, idli mix or dosa mix? So you know that idli mix or dosa mix might be more popular in South India than North India. So it might be the case that the confidence level which you are looking for this pattern could be less in if I look for Ranchi or if I look for Allahabad or something like this. Whereas the confidence level will be high when I say it is Chennai or say Kerala or say Karnataka. So that matters a lot. So you have to have some confidence level also. So confidence levels may differ as well. And it is not necessary that always higher confidence will actually attract you. Sometimes lower, like if I may be interested to have some pattern which has confidence level of 70% as well. Not necessarily that always you'll be having 100%. It actually depends on say domain. Say like suppose purchasing of a cloth, the confidence for purchasing a cloth might not be same to what purchasing of a car. Because if I say that if 100 customer visits the shop, then there is a possibility that 70 customers out of 170 customer buys clothes. But if 100 customer visits the car agency, it is not the case that 70% will go for the car. So in that case, it might be the case that only 30 is going for purchasing the car. So in case of clothes, it is 70% confidence, whereas in case of car, it is 30% confidence. So it's not like that the confidence of 30% in case of car is negligible. No, because the reason is that the cost of car is high, the profit involved in car is high in compared to clothes. So even if one car like 30% confidence, 30 customers are going for car, will lead to more profit than if even 70% of confidence of purchasing a cloth. So that sort of things we have to look for in cases of like pattern evaluations, and when you to look for pattern to be accepted as relevant one or knowledge. Okay, anything else? Hello.
No, sir. It's clear.
Okay, so I think you are well aware of the applications. Like if I'll just move on to that application part. If I'll just, this is what is data mining. As I told you that it is known as knowledge extraction and data pattern analysis. Sometimes we call it a data archaeology. Sometimes we call it also information harvesting. Then management terms we call it as business intelligence also. So there are so many names for this. Okay. So it is actually what we are looking for, extraction of interesting informations or patterns from data, maybe from large data or small data as well. Potential applications, obviously it can be used for market analysis and management. In terms of market analysis, it can be used for target marketing, customer relation management, market basket analysis, cross-selling, market segmentations. Certainly, I'll talk about in detail what is market basket analysis. This I'll be talking about all about this market basket analysis in case of association mining. Okay. Then we have risk analysis and management, where actually you look for forecasting, say Financial forecasting is very much popular. Say stock forecasting, bank forecasting, bank data forecasting, and all. All this forecasting is very much useful these days because people are actually investing money in different, you can say, investment plans. Even people are actually taking some stocks also. So all these will be part of that. Obviously, in terms of debit card, credit card, and other online transactions, this fraud detection is very much prominent field to work. So we have fraud detection and management as well. We do go for text mining analysis and web mining analysis also. It might be useful for intelligent query answering as well. So market basket analysis, if you go for, like as I told you, that it can be credit card transactions, loyalty card, discount coupons, customer complaint calls, or lifestyle studies. All these comes under this. Okay. Then uh, target marketing is actually some clustering of customers which you look for. Okay, in terms of interest, income level, spending habits, etc. These days, I think this becomes a prominent analysis in case of marketing. Okay, so likewise, we do use of associations, correlations, predictions, and other things. These are other things: customer profiling, identifying customer requirements, then say some summary informations like multi-dimensional summary reports, statistical summary informations. All these can be used for. Actually, statistical summary information, we make use of data center tendency and variations. There are so many formulas are available through which you can have reports and all. Then you have corporate analysis and risk management, where actually you do some sort of finance planning and asset evaluations, like cash flow analysis and predictions. Then cross-sectional and time series analysis. Time series analysis, any stock exchange prediction is actually a time series analysis, or any bank related data prediction is also a time series analysis. Time series analysis is actually, when you refer it, it actually has time component with the data. That means each data is having a timestamp. So it is very much useful. Resource planning, you can do some sort of monitor competitors and market directions. You can do some class based pricing procedures. You can do some sort of a set pricing strategy in a highly competitive market also. So there are so many things you can do with this. Fraud detections, obviously, it can be, the examples are auto insurance, then money laundering, medical insurance, credit cards, phone, and like all telecommunication services. All these comes under this part. Similarly, uh, some other applications which is very much useful for data mining is, I can do go for sports also. Like even people are working on analysis on IPL also, and I think many of the management institute research scholars are working on this. We work on, say, NBA also. You know that basketball association. Uh,
For better performance of the player.
yeah, yeah. It is not only the player, but it also for the, like it can be for the team, it can be for the promoters, it can be for the owners also. Okay, so that is there. Certainly, there are many things which you can do that. Like you can predict the scoring habits of the player also using their past scoring uh, data and all. You can also predict the winning confidence of the particular team based on the past data. All these are actually part of predictions and all. I think lot many papers have already written in these fields. Like you can always go for it. And surprisingly, and it is actually, I can tell you that most of the papers which actually talks about such stock and sports like IPL and other uh, big bass league and all these are done by the management institutes and management research scholars. So it is good and it is, I think it can, like, you may motivate for such things and also. Okay. Uh, so as we have already discussed this particular figure, I think you are well aware of that. If you look the steps, you can see that what we are doing is that first of all we have to go for the learning the application domain. That means you must have the relevant prior knowledge and goals of the applications. That means it is not always the case that you always go for analysis of your own system. Rather than you may be asked to analyze the data of other system which is not known to you. And in that case, certainly you need to sit with the customer and you must be aware of the domain as well. Okay, then only you can analyze the thing. Uh, Certainly creating a target set data, that is data selections. So we look for task relevant data and all. Then data cleaning, pre-processing, that may take 60% of effort. And then you may move to data reductions and transformations. Just I have given you some example of that. Find useful features, dimensionality, variable reductions, invariant representations, all these comes under that. Whereas when you look for data mining, choosing functions of data mining, then certainly you can go for summarization, you can go for classification. Let me just summarization, then classification, then regression, association, clustering. All these are mining techniques which you look for. As I already told you that choosing the mining algorithm is a big issue. It's an issue. And certainly there is no hard lines and there is no algorithm through which you can say that I can choose algorithm. It is actually very much, you can say, logical in nature, and the person involved in analysis could apply all the knowledge of the domain, background knowledge, knowledge of the data, and with the conversation with the customers, you can decide which algorithm to be used for particular task. Then the next one, once you have algorithms and all, it may be one algorithm or it may be you may go for multiple algorithms. So in that case, after that you go for search for pattern of interest, that I already told you that it comes under pattern evaluation, and then knowledge presentation also, where actually you visualize the knowledge. uh, as well as knowledge presentation is concerned, certainly I think basic presentation, you know, that you may use of may use graph, may use of pie chart, you may use of uh, histograms, and there are some other techniques also, like softwares like Tableau and softwares like even like Microsoft softwares like uh, Microsoft Excel and all. These are having lot many facilities where actually you can visualize the data or pattern, considering multiple features at a time. Not only, like, it cannot be only that you have just two-dimensional features, rather than I can have multiple dimensional features also. That means multiple features could be there, and I can visualize it in three dimensions, and as well as also n dimensional space also. So nowadays visualization becomes very much attractive also, and very much user specific also. So that is what. And if you do everything, then what do you call it as last stage is actually you have discovered knowledge. Okay, so that is what the steps involved. What is actually the when you call it, like, where actually business intelligence and data mining actually works together? So you can see that uh, there are levels of like, you can say, components are involved. So decision making is in top level, where actually end users are involved. Then next level is data presentations, then data mining, data exploration, then warehouses, smarts, OLAP. OLAP stands for online analytical processing. I'll talk about little bit on this also. And then there is data sources. It can be paper files, database systems, or some online transactional processing also. So all these actually, when you talk about this, these the task of this warehouse databases and this all integrating all these resource heterogeneous data points are actually work of DBA, database administrators. Okay, when you look for mining and other things, this is actually task of data analyst. Okay, this data analyst is actually a skilled person, or you can say it can be these persons are actually software engineers and all. Then as far as data presentations visualization is concerned, then this business analyst will come in picture. Certainly you may be also part of data analyst also, and as well as business analyst also. So these two where actually you can contribute. And obviously end users are actually, you are looking for bosses like CEOs, directors in university, like vice chancellors and all. Those people are actually responsible for decision making. So all you process from bottom to top, and you present your presentable knowledge to this end users to take decisions. So that way it flows. Okay. So certainly a set of people can be fixed in different slots. So that is what data mining, where actually business intelligence comes together. Is that fine?
Yes, sir.
Okay. So this is typical architecture of the data mining system. Okay. It could be like data mining is not only done on data warehouse, but rather it can be done on databases as well. So it can be done on databases, it can be done on data warehouse. So it can be done, and obviously extraction of the data, then going for data mining engine is there, which actually responsible for is executing the algorithms. And then some pattern evaluation techniques. This is a knowledge base where actually metadata is there. This metadata is very useful for all this evaluation and mining. And then you can have a graphical user interface where actually you can look at how my pattern looks like and all. And obviously this graphical user interface could be also used for the entire techniques, like maybe used for feeding the data, maybe used for feeding the algorithms. Like suppose when you go for using a particular, say, data warehouse tool or data mining tool, then it may provide you some graphical user interface where actually you can choose that, okay, I can feed my data, or I can call the file of the data through on this. Then I can choose algorithms out of the drop menu, and then I can make use of I can set some parameters upon which it can be evaluated, and then finally I can execute the particular task, and I can get some pattern out of it. This is what the flow which works on. So this is a typical architecture of any data mining system. Okay, let me tell you one thing, that there is no need to know a very specific knowledge to do this task. That means data mining does not require that you know Java only, or you may know C++, or you know Oracle. What data mining says is that I'm just providing you the techniques, methods, algorithms, and constructs, everything I'm providing you. You can choose any application and any sort of language which can provide such facility to you. That means you are free hand. That means any language, any application could be referred as data mining language. Only the thing is that language should provide all the construct which can be useful for my task. Okay, so you are free. So it is not bound to some specific language, or not bound to with some specific applications. So you are free hand in that case. As I told you that as far as mining of the databases is concerned, we are not like restricted with warehouse only. Rather than I can do mining on any type of data. I can do on relational database also. I can do on transitional database also. Transitional database is normally. Do you have any idea about transitional database? Do you have any idea? Anybody?
So the stock market transactions,
Stock
which
market
happen.
transactions. Okay. And anything else?
So sales data of like
Sales data. And normally, transaction data is having just two columns. Okay. Uh,
So database from banking systems.
database from banking system could be like transaction of like saying withdrawing of money or money
yes, sir.
deposits. This could be a transactional data. Very like
Transactions from Paytm.
transaction from Paytm. Yeah, that is also one transactional data. uh, Very famous data you always be having is that whenever you go for retail market, sort of Big Bazaar, Pantaloon, or any such market, whatever like bills they are actually producing for you is actually a transactional data. Okay, that means what they are producing is a transaction ID for you, and then set of items you have purchased. So advanced databases or any sort of repositories which may be object oriented or object relational, spatial, time series, temporal, text databases, multiple databases, heterogeneous databases, or World Wide Web, any data you look for is actually I can do mining on that. So we are not restricted with only specific any data or data format. Rather than I can do only the thing is pre-processing might be different for all different type of data, but rest I can apply almost all the algorithms in all type of data. Uh, Maybe in some cases few algorithms might not be applicable, but almost all the algorithms I can use depending upon your requirement. Okay. Uh, as far as data mining functionalities are concerned, so what I'll do right now is that we'll be having a 5 minutes break, and then we'll come back. Is it okay? Hello.
Yes, sir.
Yes, sir.
So we'll be having a 5 minutes break, and then I'll come back. Huh?
Okay, sir.
So we'll proceed for maybe I'll go for another maybe 45 minutes and 1 hour class. Huh? So it is almost the introduction part is over. We'll now go to some mining task, and we'll talk about how this mining actually taking place. So just wait for that. Am I audible?
Yes, sir.
Okay. So everybody is on available or gone for a break?
So I think they are gone for break. So they will coming back in 2-3 minutes.
Okay, okay, okay. Then fine.
I think people are bad.
Okay, should we start?
Yes, sir.
Okay, fine. So as far as data mining functionality is concerned, is actually you can see that we have some sort of characterization or discriminations. I can go for it. Uh, what we call it as generalized, summarize, or contrast data characteristics. So like suppose I can go for like taking that what are the dry versus wet regions analysis. This is something which I can go for. Uh, I can go for say medium spenders to high spenders sort of analysis also. That is what we do. Association mining is actually talks about some correlation and causality. This could be multidimensional as well as single dimensional association. Like suppose for example, what we are looking for like this. If you look on this, just a minute.
Sir, one student is trying to join. Please allow.
Okay,
Deepti.
okay. Just a minute. Give me 1 minute.
Yes.
Yeah. So fine.
Yes.
Okay. You can see that this is actually a multidimensional association mining, we call it, where actually you can see that dimensions, age, income, and buys are involved. So there are 3 different features are involved. So it is multidimensional association rule. What we are actually specifying in this rule is that if a person X is between age of 20 to 29, and the person is having the income which is 20,000 to 29,000, then there is a high probability that that same person will buy a PC, personal computer. So this particular rules I have generated these rules out of the association mining. That means by applying some set of algorithms on some set of data, I can generate such rules. Okay, and certainly like suppose some person comes to you and or come to your shop and his age is between this and income is between this, then certainly you may offer some sort of component or some sort of products which is equivalent to personal computer or say maybe other devices. So there's a high probability that it may go for it also. So that is what we call it. Similarly, I can go for classification and prediction also. I think we are well aware of this. We make use of decision tree, then we make use of classification rules. Classification is actually referred as supervised learning. Uh, Reason is very simple, that whatever data I'm using for classification and prediction, the classes are known to us. So classes are known. What we try to do is that out of the data, I'm trying to get the rules which can actually classify the unknown data. So it's a trade-off between rules and classification accuracy. Okay, that by applying algorithms, you generate set of rules which can actually classify the data, and then based on the new data, that what is the degree of accuracy, it actually talks about how the classification is good or bad. So it accuracy always matters in this case, and in case of low accuracy, we may go for re-execution of the classification also. So that is what we do it. Whereas cluster analysis is unsupervised learning, where actually classes are not known to me. Rather, the natural properties of the features actually direct us to the different clusters. So, simply, I think, for example, I can say that fine, that I can have 2-dimensional x and y, and I can have like points like this. Okay, like this. So I can say that this is my one cluster, this is my another cluster, this is my another cluster, and this is this referred as noise. That means just one point is there and which cannot be a part of any cluster, whereas these points are clusters. So clusters could be of any shape. It's consist of a group or a dense data, and obviously each clusters and if I say that how these clusters are formed is actually we look for maximizing the inter-cluster distance, whereas minimizing the intra-cluster points distance. So we always minimize the intra-cluster points distance, whereas we always maximize the inter-cluster distance. So that is what cluster does on the data. Okay, so that is what we have. Then obviously there are some trend and evolution analysis we can do also. This is known as like using regression analysis. We can do that, and we can apply some of the algorithms like support vector machine, SVM. Then we make use of some ANN also, artificial neural network, say back propagation, multi-layer perceptrons. Then further these days, I think you are well aware of that deep learning we call it. So when we are actually the more number of hidden layers will be used, then obviously trade-off is always there, because deep learning is a complex network and it actually incurs a high cost. So depending upon that, what is your requirement, you can choose the algorithm out of it. Okay. So when I say summarize the entire data mining part, then obviously what we call it as, it's a confluence of multiple disciplines. So data mining is actually make use of statistics also. It also talks about visualizations. It also talks about information science. It deals with machine learning and non-machine learning algorithms. It also talks about database technology and warehouse technologies. And obviously application as far as is concerned, it actually can be applied in different disciplines. So it is almost in all the disciplines in today's world, these mining techniques are used. Say anything, bioinformatics, science, chemistry, mechanical, electrical, electronics, everywhere people are using it. Only the thing is the intensity and scale might be different, but it is usable. Okay, this is what we do it. So this is what introduction is. There are some issues in data mining. Issues, as I told you, that always be issues that how to integrate the heterogeneous data, how to get the task relevant data, how to choose algorithms out of the basket of the algorithms, then how to choose the patterns which actually in more numbers, which could be having high utility, novelty and confidence, and could be useful for decision making. So all these issues always be in part. That means we are providing so many things. We are providing the ways to handle the noise, the ways to handle the data cleaning, the ways to transform, ways to integrate, everything we are providing it. Then further, I'm going for, we have devised so many ways to extract the data which is task relevant. Then we have several category of mining algorithms which could generate different set of patterns out of it. Okay. Certainly, we have the mechanism of pattern generation, then pattern evaluation and all. But when you look on the same, this particular figure, then I can tell you that each step actually is actually, you can say, each step having their issues. As I told you, the issues here is how to integrate the heterogeneous data. It is not easy because you are talking about a large frame of data, or the timestamp is very large. Over the period, different set of software applications were used. So interaction between those applications could not be easy. So that is what we mean. Then selection of data always be dependent on how wisely or how far effectively you have designed your query, because that actually extract the data from warehouse or databases. So that again become issue for you, that always try to frame such query which is actually targeted, or which could be, which can actually extract the required information. Data mining, then choosing an algorithm, choosing the category of algorithm is a big issue. Pattern evaluations, then how, what sort of parameters should I go for evaluation is again issue. Then there are many ways of representation of the patterns. So which one is good for you and your say end users is always be issue for that. So there are so many issues involved throughout. But within this constraint and issues also, what we are getting is very extraordinary, very beneficial also, and very useful also. So this is something which you can say that data mining is playing a very important role in today's world of say business. Okay, and and widely used. Even if the moment you will join any company, you'll find that you'll be just dealing with any of such analysis which could be indirectly or directly related with this domain. Okay, so that is what we are looking for. Fine. Okay, so I'm just finishing here the introduction part, then I'll move to so I'll move to the first part of the mining algorithms, which is known as association mining.